I've had to start and restart every single recording I've tried to do today. I don't know what's going on with my camera. I think it was just that the storage was a little full, so I've kind of moved some things around on my end. So anyways, I'll just start over. That's okay. Hey guys, it's nice to see you again. From my perspective anyways, it is a little hot, so if I seem a little bit distracted, it's because the heat is messing with me. I'm just not going to compete with the AC, honestly, because it makes a lot of noise. And I don't feel like doing that to you guys. So I will just suffer and bear through it. Anything for science. So we're going to start with the first rock. As I said in my prior recordings that I had to get rid of because the camera is playing games, I have several rocks that look like they are conglomerates slash brechas. Some of them are, some of them aren't. Some of them are actually igneous in nature, which I guess sometimes you can confuse igneous rocks for sedimentary conglomerates and brechas or other sedimentary rocks, just because, you know, rocks kind of look the same from afar until you actually start investigating them. And as a little refresher, a conglomerate is a rounded collection of rocks with a matrix, while a matrix is just like the glue that's basically holding all these little pieces of rocks together. So if you pick up a rock and it looks like a bunch of rocks are glued together, that's probably a conglomerate or a breccia. Breccia is angular, conglomerate is rounded. And what I mean by angular is that it's still got sharp little edges, like it's still got points to the rock because they haven't been rounded off yet, which means it hasn't actually gotten that far from wherever that rock was originally glued. So yeah, this is a conglomerate. Pretty big guy. Very heavy. The density of this rock makes me think it might be more igneous in nature, but I would have to do further investigating to see that actually. I do have some, I'm not sure if conglomerates can be heavy or not. I really will have to look into it and then just let you guys know as I go along. This guy is a breccia. Little tiny guy. Much lighter in density and also in size, like much smaller in size. You can actually see the glued rocks just kind of cemented in there by a darker matrix. That darker matrix is made up of calcite because it does fizz. And the white rocks are probably more silica in nature. It could also be calcite as well because the whole rock did seem to fizz. And it was kind of hard for me to tell what was fizzing and what wasn't. So yeah, that's a breccia. See the difference? Angular. Rounded. In any case, let's move on. Now this guy also looks like it could be some kind of collection of little rocks. However, this is not a conglomerate or a breccia. It is actually volcanic tuff. So, volcanoes are really cool. I don't think I need to qualify that statement, so I'll just move on from it. I'm not taking any questions. Volcanoes sometimes do this cool thing where like a bunch of rocks just kind of, like a bunch of the magma melds together and then just stays like that pretty much forever after it comes out. And this is an example of that. A tuff just means that all of the grains in the rock are smaller than like 4 millimeters, or most of them are, while a volcanic breccia would mean that it's basically all the rocks are bigger in size, or most of the rocks are bigger in size than 4 millimeters. Because most of the grains in this rock are small, it's a tuff. And it's got mostly lighter material, so although volcanic tuffs don't really differentiate between mafic and felsic material that much, it's just kind of the catch-all term for something like this. Now, this guy, I'm going to take a break from the conglomerate-looking rocks so you guys don't just keep looking at collections of rocks glued together. This is another sample of diabase from what I showed you guys last week. Very dark material, little, and it is found in exactly the same place that I found the other sample of diabase in. I just completely forgot that I had more than one sample, so I didn't show you both of them in the same week. But yeah, this was also picked up in the exact same area. I split them both. This one was a nicer split because I was able to get more of the rock to show up on the inside, and the whole rock didn't crumble in my hands when I did that. So that's why it's a flatter surface like that and it's longer. This guy is a quartz vein in a limestone rock. So the gray is limestone. If you remember from what I said last week, that means that basically the gray limestone is just it just means that there's like more biologic material in there, and it does fizz pretty actively. The quartz vein, the white stuff, doesn't fizz at all. So really cool stuff. I think I found this in a parking lot. So sometimes if you, at least in my geology classes, they would take us to the oddest places. Like they would stop on the side of the road to show us the rocks that are basically coming off of the hills. They would stop at parking lots or little hills outside of other, like there would be a place that's an attraction for people to go to, like a building. We wouldn't be there. We would be on the hill outside the place because that's more interesting to a geologist than the actual building. So yeah, this I got from a parking lot of all places because apparently there's quite a few cool formations in Pennsylvania that just show you quartz veins coming through a limestone rock, and this is an example of it. This is actually a really cool sample. Don't ever let anyone tell you that limestone and quartz is not that interesting. They're lying to you. Now this guy is a really, really interesting rock. This is a milky quartz, but it looks a lot like opal. The difference is honestly just the crystal structure. So I'll show you guys. It could be mistaken for opal. I had to do a whole bunch of research and some tests to see. And I also had to use my little lens here. This little lens. I'll show you guys how it actually looks because I don't think I've shown you guys this yet. So, this is the lens I use to actually look at the crystal structure and the sizes and stuff like that. Those are not that cheap. So if you're gonna get one, be careful with them. That's a hefty, price for such a little piece of equipment. But it's because it is so useful. And if you're gonna use one of those, a tip that I got from my professors is that you should probably hold it up to natural sunlight. So that way your back is to the sun and you have your little lens here like this. I'll just demonstrate. So you hold this rock like so. Let's pretend that the sun is behind me. And you just do this. And you do have to get that close because you're not going to be able to see it from afar. It is not a magnifying lens in that way. You have to get close to be able to see it. If you spend a lot of time looking at rocks, you will spend a lot of time practically kissing them. So yeah, this is a milky quartz. Just said so because of the color of the quartz. The crystals, there's actually visible crystals here, a crystal structure to it. If it was just an amorphous blob of white, it would probably be opal. Alright. This guy is another sample of conglomerate. And you can kind of see the difference between them, which makes me keep thinking that this guy might actually be an igneous granodiorite or something. Because this is much heavier than this guy, and they're supposedly both the same rock, but this doesn't feel like, this just doesn't look like the same rock. Let me know what you guys think. Now, this is a classic example of a conglomerate. Mostly anyways. It has a little point here, but that's because I probably picked it up before it could be rounded off as well. But there's not really any other angles to this rock. It just didn't get finished actually completely rounding off. And you see all those like little class of rocks welded together, that's all silica, because conglomerates tend to be mostly made up of silica rocks, because they're the only ones that last long enough to be rounded off that long, as I've already explained before. This is a little bit of iron staining. Really cool. Yeah, you can see that in pretty much a lot of rocks. Now, this guy is a little confusing. I'll try to explain what I'm so confused about, but essentially, I know what the white stuff is. Here. The white stuff is very likely to be a quartz vein. I've tried scratching it. It doesn't scratch. It doesn't fizz. So it is likely to be quartz. The problem is the matrix. No matter how I look at it, the matrix is very likely to be also very silica heavy. I just can't tell exactly what material I can call it. Because it could be hematoid quartz, which would explain the reddish color of the matrix. It could be chalcedony. It could be agate. It could be a banded agate, essentially. But banded agates don't tend to look this way, so I'm very much doubting that. It could also be it could be something crazy, like some basalt in there, which would explain all the little holes that you see in the red material. But yeah, so it's kind of like the white stuff is quartz, the red stuff is unknown at this moment. If I ever find out what it is, I will revisit this rock because I'm very curious about it. It looks so simple, but it's so difficult to identify once I actually start looking closely at it. Now, there are two more rocks. This is a tiny little guy. I have bunches of tiny little guys. I don't know if you can tell the color specifically through this lens, but it's actually a pinkish color with like white spots throughout. It looks very like kind of milky, but it doesn't rub off on your fingers. It does scratch easily though, and the whole thing fizzes. So my assumption is that this is very heavily like limestoney. However, the pink color is what has me a little curious, because that can either be, this could either be manganese, like, or iron oxide, and that will explain the pinkish color, or it could be a marble, like a metamorphosed marble, because marble is just basically a metamorphic sample of quartz, like, not a quartz, of limestone. So, and that tends to have pink and white crystals of calcite in it, so that's probably what it could be. It's very, very pretty sample. And the whole thing doesn't fall apart easily, and it doesn't start changing colors once it starts fizzing. So I'm thinking I am leaning more towards the marble. Because remember the other sample that I had that was pinkish, whitish, and it started to turn like an ugly brown color after I put it in after I put it in vinegar. That's closer to like a pure limestone sample, like a pure calcite sample, than the other guy that even though it fizzes, it doesn't change color at all. That probably is marble. Now, this guy is interesting because this dude, this is the last one as well for today. This guy looks so, I guess I should say common, not boring. It looks like it's just breccia. I'll show you guys right now. Looks like normal run-of-the-mill breccia from afar, but then when I actually start looking at it closely, I can see that the black minerals are in here, first of all, are very crystalline in structure. They definitely have like a shape to it. It's not just random rocks that have been ground down and glued together. And they're very, very shiny. So after a lot of investigation, it looks like this guy, more than just some random conglomerate, is actually a black tourmaline sample embedded in quartz, otherwise known as a tourmaline pegmatite. And a pegmatite is basically just a really big sample of an igneous rock. Like all the minerals are not only coarse, so you can not only see them, but they're big. Like, look at this guy. This is one mineral. This dude right here. See how big it is? That's probably why it's a tourmaline. Tourmaline tends to be pretty big in terms of like size alone. And all the other white stuff is just quartz that it's embedded in. I bet if I kind of took my time and slowly took out the black crystals from the rest of it and then polished them, I'd have a very pretty sample of tourmaline. I may be tempted to do that depending on what you guys think or depending on my own willpower later. We'll see how long that actually takes to do. I imagine it's not a quick process. And that's pretty much all I have for you guys today. I know it's a very short video, but a lot of these didn't take long to investigate. Actually, no, it took longer to investigate than to explain. And of course, I'll take photos, and I'll take a nice little group photo for the end. Thank you for being here today again, and I'll go ahead and keep sampling all of my rocks. We're just gonna do this until I run completely through my collection, and then I can start collecting more as I go on and start doing other videos explaining other concepts. If you guys ever have any questions or you have any video ideas for something you'd like me to cover, go ahead and let me know. Until then, just, enjoy yourself, go out there, see what you can find, and stay curious.